All right, so on this one it says that you're in the Empire State Building looking at the Chrysler Building. So I'll call this C. It says when you turn 145 degrees, so that means this angle right here is going to be 145 degrees. You see the Statue of Liberty. And you know that the Chrysler Building and Empire State Building are 0.6 miles apart. And the Chrysler Building and Statue of Liberty are 5.7 miles apart. And you want to estimate the distance between the Empire State Building and the Statue of Liberty. So I'm going to call this X. There's the length that we're looking at. We have a pattern of SSA. So again, it indicates we're going to use law of sines to solve this. The side opposite the given angle is larger. You know there's not going to be any other triangle because this is a obtuse angle here. So you're good on this. So if we set up our known ratio here, and so what we need to find first is this angle S. Once we find that angle, we'll know angle C, and then we can find this last piece of information, X. Okay, so when we set this up using law of sines, we do have to find S first. So the sine of S over 0.6 is equal to our known ratio, the sine of 145 over 5.7. Okay. If we multiply both sides by 0.6 and solve, we'll get our sine ratio. So the sine of 145 divided by 5.7 times 0.6. There's our sine ratio, 0.060 approximately. And so to find the actual angle S, we need to take the inverse sine of that ratio. So we take the inverse sine, highlight the ratio, and this gives us our angle measure of about 3.5 degrees. Okay, so that is this angle right here. Once we know that angle, what we can do is subtract our original angle of 145 and this angle that we just solved for, and that's going to leave the angle for C, which is 31.5 approximately. Okay, once we have that measure, what we can now come back and do is find our X value. So we use the law of sines again, but this time our unknown is X over the sine of the angle opposite it. Set that equal to our known ratio. I'm going to use my same known ratio, only this time the side length goes on the top. And because I'm solving for a side length and not an angle that's embedded within a trig ratio, I'm just going to use the solve feature on the calculator. X over the sine of this angle measure that I just solved for is going to equal my given ratio of 5.7 divided by the sine of 145. Close it off and solve for X. When I do, I get my actual length, which is 5.2 approximately. And that was the measure that I was looking for.